This is exercise A here, and quite difficult exercise, I would say. And we will try and solve this. And the first thing we should do is find the indefinite integral of this function here. It's a quite complicated function, but we get a hint here that u is x to the power 3 plus x. So here we should use substitution, right? So I just write the function like this, and we should then let u be x to the power 3 plus x, right? That's our core here under the square root sign. So that's a pretty obvious choice of u. And then we find the derivative of this, which is 3x squared plus 1. And then we get dx by itself. We multiply by dx on each side. And I then get this expression here, right? Multiply by dx here, and it disappears, and it comes up on this side. And then we should isolate dx, so we have to divide by 3x squared plus 1 on each side, like this. And then this disappears, and we get dx by itself on the right hand side here, and on the left hand side we have this expression here, like this. So then we that's the method of substitution. First find the core, put up the derivative of the core, and then just multiply and divide and so on to get dx by itself on one side, and then we actually do the substitution. And then we write this thing all over again, but we substitute two things here. The first thing is the core, this one. I've called this u, so I can then call this, I can put u in here like this, and then it's dx. Dx is equal to this, so instead of writing dx here, I can write du divided by 3x squared plus 1. So I made a substitution, and then we see that we're going to divide by 3x squared plus 1, and here we have 3x plus 1 in the denominator if we multiply it inside here, so we can shorten this thing against this thing here. And then we are left with the integral of square root of u du, like this. And that is an integral which is possible to integrate. We had a really difficult integral here, but by taking substitution, we get a much more easier integral here. This is still a bit complicated. If you want to integrate square root of u, we have to rewrite it as this. And then we use the power rule for integration, which says that, so now I can integrate, it's that 1 divided by 1 more than this times u to the power of 1 more than this, and then plus c, of course, right? It's the same rule which we use when we, for example, integrate x to the power of 3. Then I take 1 divided by 1 more than 3 times x to the power of 1 more than 3, right? It's the same rule here. So I get 1/2 plus 1, that's 3 over 2, times u to the power of 3 over u plus c. And then we have a complex fraction. I just multiply by 2 here and here. So I can shorten here, so I get 2 over 3 times this expression. And this fraction here, we need to know these rules here, can be written as the second root of u to the power of 3. That is this rule that every expression with roots, for example this one, and the nth root of r to the power of a to the power of r is the same as a to the power of r over n. And in this case here, I use this backwards. The number 2 should up here and number 3 down here. And just one thing here, the second root is the same as the square root. So then we have done this. So then I've managed to integrate this thing here. Wasn't the easiest one, but I managed it. And then after I have integrated, I can now change u, substitute u again, and u was the core x to the power of 3 plus x, right? So substitute back, sorry, plus c, it's not, we have integrated, plus c, like that. So then we have done exercise A, if I'm not mistaken, yes, 3 marks for me here. Thank you very much. And then we should now find, yes, we have 2 functions here. F, this one, this function here is this one, and G, this one here is this one. And it says we're going to find the area here, right? Write down an expression for the area R here. And if we want to find the area between 2 graphs, we use this formula. Is the integration of, we have to take the roof first. The roof here is g of x minus f of x, which is the floor of this area, dx, and the limits here is from 0 to 1, right? So this is what we have to calculate, this thing here. And then I just try and do this so I can see what I'm doing here. I just changed my color here so it's easier to see. Let's take blue here. So R is then equals to the definite integral from 0 to 1 of g of x, which is 6, to have a parenthesis, 6 minus 3x squared times x to the power of 3 plus x, minus, this was g of x, and then minus f of x, which is square root of x to the power of 3 plus x, like this. And here we have to really do something clever, because this I can write as r is equals to 0 to 1 of 6. And then if you look at these 2 terms here, we have this factor in common. So I can put this factor outside the parenthesis here. So I put sorry. Yes. Let's first, there's a lot of stuff here, but let's first make sure we have the right sign here. We don't mess with the signs. And the first thing I do here is just put minus here, and then let's try here. I can take the square root of x to the power of 3 plus x, like this, put it outside a bracket, and then I have 3x squared left in this term, and then it's actually minus here. And what's left in this term? There's nothing left in this term. Then we should write 1 like this. But be careful now. If I now multiply this in, I get minus this times this, which is minus this, and I get minus this times this, which is plus. So I have to change the sign. If you put a minus outside the bracket here, we have to change this sign here, right? If I now multiply inside, I will see that this is the same as this. So there's my expression for this area, how to find this area. So that is the answer on exercise B. And then we should actually calculate this area. So we have to calculate this stuff here. So we have to find the, let's put R here. We have to calculate this, square root of x to the power of 3 plus x times 3x squared plus 1, like this. And here we have 2 terms. And remember, if we want to find a definite integral, we have to use Newton's fundamental sentence here, and we integrate term by term. The first term, it's easy, that is just 6x, integral 6 is 6x, and then minus the integral of this, which is quite messy. But if you look at exercise A, that was what we did in exercise A, and we got this answer. So the answer is 2 over 3 times square root of x to the power of 3 plus x. And we don't need plus c, right? When we have definite integrals. So we have done the hard work already here in exercise A. And then we just put in 1. First, the upper limit, 1. 6 times 1 divided minus 2 over 3 times 1 to the power of 3 plus 1. And then minus, you have to have another bracket here, right? Because it's minus here. This is the upper limit, put in 1, and then minus when I put in the lower limit, and we then get this. So we get square root of 0 plus 0, and x is 0, so we get 0 here, right? So this, all of this would just be 0, so you can just forget about this. And then I get 6 minus 2 over 3 times the square root of 2. The square root of 2. And that is the exact area of R. The area R, the value of this is 6 minus 2 over 3 times square root of 2. So that was exercise 8. So not the easiest one, but I hope you did understand what I was doing here.